Okay, let's look at finding the area between curves. So if I want to find the area between the curve x squared minus 1 on this interval, -2 to 1, we learned from the last section, the fundamental theorem of calculus, is we find the antiderivative and then we evaluate it at these limits of integration. If I do that and I plug in 1 for x minus, I plug -2 in for x, look what happens. My area is 0. Why would we have an area of 0? Well, if you graph it, and this is why I say you should always graph these first, you can see what's happening is there's a positive area and a negative area. In fact, they're going to be exactly the same. They're going to be that 2/3 piece. So what I have to do is I have to the negative area absolute value it. So notice what I did. Instead of going from -2 all the way to 1, I just went from -2 to -1 and found this area. Then I went from -1 to 1, and this area I did the absolute value, so I got positive area. So you have to be careful if you're doing something like this where your function is looking at the x-axis. Now, if it's just two different functions together, you're finding this area here, and you can just simply find it by subtracting them. You don't have to do the absolute value, as long as this function, f of x, stays above this function. Okay, so again, you should graph it to make sure. So let's find the area bounded by these two graphs, and I have this interval -2 to 1. So the first thing I do is I look at a picture, and I see certainly that the top graph does not pass the bottom, and so I can simply just subtract these. So if I subtract them, or I first find the antiderivative. Okay, so that's what I've done here. This was x squared over 2, multiplied it and got x squared over 4. This, of course, is 3x. I went ahead and distributed the negative and the negative, positive, and then minus x. I plug in these values, and I get my decimal of 8.25. Well, let's look at an application of this. The U.S. Census Bureau compiles and analyzes data having to do with income distribution of U.S. families. So this data was reported below, and we have what's called this Lorenz curve. So X represents the cumulative percent of families at or below a given income level. So that's X. Y represents the cumulative percentage of total family income received. So say, for example, if X is 0.40 and Y is 0.11, this means that the bottom 40% of families, incomes less than $39,000, received 11% of the total income for all families in this year. Or if we look at this row right here, this says the bottom 60%, okay, so of families received 26% of the total income for all families in 2011. So this graph of y equals f of x is called a Lorenz curve, and you find this by regression analysis if you've had some statistics classes, but we're just going to use it. And absolute equality of income would occur if the area between the Lorenz curve and y equals x, this line, equaled 0. So in other words, there wouldn't be any difference in the distribution of income. All the income would actually, absolute inequality would occur if the area between the Lorenz curve and y equals x is the area of the triangle. In other words, it ate up all this area here, and this is saying that the income would be in the hands of one family and it's not being distributed. So of course, in actuality, the Lorenz curve lies between these two extremes. So that's what we're looking at. is to see if, as the shaded area increases, the greater the inequality is. So this Gini index gives a single number, and it is based on this ratio of the area of these two areas, I should say, I'm sorry. The area between y equals x and the Lorenz curve, and the area between y equals x and the x-axis from 0 to 1. So we have this formula that, as you can see, you're finding a definite integral and then multiplying it by 2. The closer the index is to 0, the closer the income is to being equally distributed. The closer the index is to 1, the closer the income is being concentrated in a few hands. So if we're given the Lorenz curve for the distribution of income in a certain country in 2013 is given by this function, I have another function that economists predict that the Lorenz curve in 2025 will look like this. Let's find this Gini index and explain what it means. Well, for the first one, I take this x to the 2.6. I do x, the antiderivative, x squared over 2, minus my f of x, which is x to the 2.6 plus 1. That's where the 3.6 over 3.6 comes in. And I get this value of 0.44. I do the same thing for what economists are predicting, and as you can see, it looks like it's a pretty good prediction, because what's actually happening is we're getting closer to 0, which says that the income is being more, in this case, equally distributed.